get started. So, good evening and welcome you all to this special session on the value stream mapping. So, I think this course, this session is designed for the people who already have the knowledge on lean management. And because again, this most of the people are likely we are circulating to our old students who has completed our Lean Six Sigma and Lean Management course from us. So, in order to have a clear understanding how some of the concepts can be applied in their real life. So, but again, there may be some people who are not exposed to the lean management also. Some few people may be there. So, for first few minutes, I will talk about some general basic concepts of lean. And then we will just, I'm not going to take this as a sort of a theoretical session for the entire 1 hour. So I'm going to give a technical session, that's the explanation, only for a maximum of say 20 or 25 minutes. Then we will take a live problem from one of the participants here, and then see how this concept of value stream mapping can be used to solve the problem and improve their efficiency, right? So that is what is going to be the purpose today. So first I will give a very brief about the lean, general basic concepts of what is lean. Then I will give some explanation, crisp explanation about the value stream mapping, what is value stream mapping, how it is done. And then we will take a real case study from one of the participants' process and then see how it can be practically applied. Okay. So lean is actually a concept which was first introduced in Japan. So all of you are aware that the Second World War was fought between 1939 and 1945. And when the war ended, then the Japan was totally devastated. So they were economically, they were devastated. So they were working hard to come out of their problems. And the United States of America, then they felt that they were morally responsible for the destruction of Japan. And they sent a lot of experts, including the quality expert, to help the Japanese people to come out of their problems. And so people like quality experts like Deming, Joseph Joran, and Phil Crosby. So these are some of the prominent quality experts who just were deputed quite often to Japan. And then in the 1950s, then this lean became very popular in Japan. So the Toyota, actually they were into the handloom business during the early 1900s. And the Toyota automobile, their farm started in the year 1935. But immediately the Second World War came and they were not very active. And they became very active during the 1950s after the Second World War. And actually they were the pioneers for implementing lean. So lean is a methodology for identifying and eliminating waste in the process. So it's a methodology for identifying and eliminating waste in the process. So when I say waste, then immediately what comes to our mind is waste means any scrap, whatever we are doing in the process. But that actually is not the only waste. There are 8 types of waste according to lean. And these 8 waste can be remembered by remembering the word downtime. So downtime is actually acronym. So each letter stands for a particular word. So D stands for defects, O stands for overproduction, W stands for waiting, and N stands for non-utilized talent, T stands for transportation, I stands for inventory, M stands for motion, and D stands for extra processing. So these are the 8 types of waste. This type of waste are found in any type of processes, whether it is a manufacturing process, or a IT service process, or a software development process, or a logistic process, or a storage process, warehouse processes, healthcare processes, construction processes.
So any type of processes, these 8 types of waste are applicable. So we'll have a quick look at what are the 8 different types of waste. So first one is the defect. So any scrap or rework, whatever we are doing in the process, so that is considered a waste because that is actually not adding any value to the customer. So when you say waste, we also need to understand a concept which is called value. So value means the activity a change in shape or form for which the customer is willing to pay. For example, you want to buy a car, so of your choice of color of your choice. So then you are willing to pay for that. So when the company is giving you the car of the choice of your choice color, then you are very happy. But suppose if because of some problem at the manufacturer's place, if they have given you a different color car and then you point it out and ask them to rework, they may be incurring some 20,000 rupees extra cost, but you are not willing to pay for that. That is called a waste. So value means for which any of our customers is willing to pay, we call it a value. And any activity which is not adding value to the customer, we call it a non-value added activities, or it is called as a waste. So non-value added activity, we call as a waste. And as per surveys recently done, we find that only 25 to 30% of activities done in a manufacturing setup is adding value to the customer. So 70 to 70% of the time is spent on non-value-added activity, that is waste. So there is a huge scope for improvement by implementing lean. So in a service setup or like a logistics or IT service, again this may go up to 40 to 45%, but still 50 to 60% opportunity is there for improvement, right? So again, any activity not adding value to the customer, we call it a waste. And out of these 8 types of waste, we started learning about the first one, defects. So any rework or any scrap, whatever we are doing in the process, that is not adding value to the customer, we call it a waste. Second one is the overproduction. So if you are producing something extra, the customer, like many times it happen, like we don't have firm orders from the customer. So instead of keeping our machines and manpower idle, we just produce some items based upon some expected order, thinking that once the customer places the order, we can directly select from our finished goods. But again, that is a very big problem, very big mistake, because if for some reason the customer order does not come through and there is no demand for the product, again, ultimately that may become a non-moving stock and that may be scrapped also. So you need to produce only the items for which you have firm order from the customer. And if you are going to produce something for which you don't have firm order, we call it a overproduction. That's a wastage. Third one is a waiting. So in our setup, you cannot say that all the processes are having the same output. For example, we have some 4 sub-processes in the end-to-end process. The first process may produce at the rate of 1,000, whereas the second process can produce only at the rate of 750. So that means always when both are running, then the many parts will be waiting for production in front of machine 2 because its output is less. So anytime getting wasted, that is going to be a waste. So anytime waiting for the next stage of production, that is going to be a waste. Fourth one is unutilized talent. So if you are not utilizing the talent of the people, if you are underutilizing the manpower, then that is called the non-utilized talent. Transportation is mainly because of layout. So if your layout is haphazard, then a lot of unnecessary movements of material will be there. That is a wastage due to the transportation. Inventory is any material you are storing either in the raw material stage or in the work in progress stage or the finished good stage, in which you have added all the value. So you have all the material cost has been included, added, all the manpower cost has been added, and all the machine cost has been added. But again, all the money you have spent, but you have not got the money returned by the customer. So that means you are going to have a lot of cash flow crunch. So that is why inventory is the biggest enemy as far as lean is concerned. Seventh one is about the motion, unnecessary movement of people. So if people have to bend a bit or stretch a bit, or they have to walk some few meters to to get the material into the storage area, this walking, bending, and stretching is going to make them tired too soon, and accordingly, their efficiency is going to be reduced. So in the modern day, so any obesity, neck pain, hand pain, back pain, these are all some of the examples of most related issues. The last one is about extra processing. That means doing more than what the customer requires. So you should just meet the specification given by the customer. So doing some extra work, thinking that the customer will be happy and then will place more order on us. We are going to do something extra. Again, that is going to be a waste. Because if that is really required by the customer, would have been willing to pay for that. If he is not willing to pay for that, then that is a waste. So these are the 8 different types of waste in any organization. Right? So whenever you are wanting to implement lean, then the first step what we need to do. So these actually we call as the 5 pillars of lean. So goal is to deliver maximum value to the customer with minimum waste. So that we can also take that the definition of lean. Lean means more with less. So you can just have the definition. Lean means more with less. That means more output with less inputs. So you have to give more features and functions to the customer with lesser inputs. Then that's when lean will be helpful to you. So there are 5 actually stages of lean. So first we'll have to define value from the customer perspective. So we should not define the value. The customer should define the value. What actually he is willing to pay for. So that is what is the value. Then the second part, that's what we are going to learn in detail now. Map the value stream. So whatever the process, end-to-end process we are doing, so we'll have to just capture all the micro level activities within the end-to-end process, so that you'll be able to identify where the wastage is happening. So that's what we call the mapping the value stream. So we'll have to each and every process, or the end-to-end process, we'll have to divide that into sub-process into sub-process into activities, so that you'll be able to clearly map what is currently happening. So that is what is the value stream. Then we'll have to create the flow, smooth uninterrupted flow. So today our discussion is going to be more on these 2 points. So identify, map the value stream and create flow. Then establish pull. So we'll have to always ensure that we are not dumping the material to our customers, but actually customers are pulling the material from us, right? So that means we are not producing anything what the customer wants. Whatever we are producing, the customer should be immediately taking it to them, so that they will immediately pay for that, so that our cash flow will be correct. Then finally, seek perfection. So whatever we are doing in these 4 activities, we'll have to keep on improving, continually improve, so that our efficiency will improve. So these are the 5 pillars of this lean. So today we are going to focus on these 2, value stream and mapping the value stream and creating the flow. Okay. So I will try to make it a bit interactive. Okay. So here, what is the difference in the first and second process, what you are seeing? Can you tell me? The top and bottom. So you are seeing the picture, right? So what actually that picture tells you? And can you relate it to your process? Anyone? So what is the biggest difference from the top and bottom picture?
Flow.
Block, bottleneck.
Yeah. So this maybe many times even you would have suppose we are having some plumbing line in our own house, right? So we are having some taps. So we are actually sometimes we find that the outflow of water is very less, right? So, for example, you are taking the water from our well, and then there is a plumbing line, pipeline is there, and then we are output is coming in the bathroom. So sometimes we find that the output is coming less. Then we just track the entire pipeline right from the source of water, that is the well, to the final output, and then we'll find that somewhere it is blocked. Maybe some external material has gone into that, and that has actually really choked the flow of water, so that the output we are getting is very less. Right. So this happens in many of our processes, irrespective of whether it's a manufacturing process or a warehouse process, logistic process, any type of process, this happens. So if the customer is asking for the material and we take the raw material and we take it to the different stages of the manufacturing or logistic, what are the different steps, without any choking or without anything. So with the continuous flow of material, we are able to keep, then we will be able to service the customer well. So whatever the customer demand is there, we'll be able to meet, provided there is no choke points in between and the material flow is very smooth, right from the first to the last part. So that's what we call as a without choke, smooth flow, high throughput, and happy customer. So we'll be able to deliver to the customer exactly the quantity required by him, exactly at the time required by him. But this is practically what is going to happen is, maybe if you are having right from the end-to-end process, from the receiving order to the shipping, if 5 processes are there, invariably we'll find that 1 or 2 processes, there are some problems. We call this a choke points, right? So, for example, the first process is producing 1,000, second process is producing 900, third process is producing only at the rate of 500 per hour. Then that's what we call as a choke point. So, since it is going to produce 500, then whatever the backend processes are there, like packing and shipping, so they are going to get only 500 per hour, even though they have capacity to produce 1,000. So what is going to happen is, if there is going to be a choke point, what is going to happen is, like, so here the first process is producing as per the plan, 1,000. Second plan is also producing as per the plan. So everything has moved. But this process, it is producing only at the rate of 500. So that means all the parts which are produced, but they are unable to pass this. So everything will lie as a inventory here, right? So again, your money is going to be blocked in this area. And then after this choke point, only 500 is going to come out of this every hour. So this material, this packing and shipping, etc., where you have equipped the manpower machinery to produce at the rate of 1,000, so they are going to get only 500 pieces per production. So they will be underutilized and they will be waiting for reproduction, right? So that means because of this particular choke point, this particular problem, choke point, so what is going to happen? So a lot of inventory is going to be created before this particular process. And after this process, again, they are going to be starved of material so that their efficiency is going to be reduced. So the choke point creates the bottleneck, WAP will build up, lower throughput, and delayed delivery. So if you are expected to produce at the rate of 1,000, but because of the choke point, it was able to produce only 500, then your output is going to be only 500. So that means your delivery time to the customer is going to be delayed. So the impact of the choke point is you are going to get a higher WAP inventory, longer lead time, higher inventory holding cost, delayed delivery and unhappy customer, and lower throughput and efficiency. So that's what is the problem faced by most of the companies. So in your company, do you have any problem like this? Can you just type yes or no? Whatever the process you are doing. So do you have this type of problems where because of some inefficiency or in a particular in-between process, then always you are in the firefighting mode. So you are not able to deliver on time to the customer, and there is a problem, right? So are you able to relate it to your processes? Okay. So that's where the doing this value stream mapping will be very much helpful to you. So again, I will just explain how we can do the value stream mapping. So again, the main purpose of doing this value stream mapping is we'll have to map the current process, the end-to-end process, right from receiving the order to the final shipping. So we'll have to again collect the data at each and every sub-process and then see where the bottleneck is there, so that we can just try to focus only on the bottleneck area and then try to get to the deeper depth of it to understand what are the activities which are holding back the material here so that we can take some action. And once you remove the choke point and you are going to create a full proper flow, then all your problems are going to be solved. So here is an example given for a recruitment process where the particular department has given a request for recruiting 400 people in 20 days. So for the recruitment process, so if you want to do the value stream mapping, so first what you need to do. So again, you can see that there are some symbols are there, like the triangle, rectangles, and ladder, like step-like ladders, and then the top middle, you can see some shape. So these are all globally standardized symbols for the value stream mapping, right? So when you want to do the value stream mapping, first start with this particular draw the external or internal customer at the top of the page and this requirement. First, we like to see who is the customer and what is his requirement. So here the customer is the production department, XYZ, and their target is to get 400 people to be hired in 20 days. So that is the customer. We have to identify the customer and the customer requirement. Then you will have to draw the entry and exit point processes to the value stream. So here we are trying to do this value stream mapping for the recruitment process. For the recruitment process, then what is the entry point and what is the exit point? So in that company, there is a process that any department, whenever they want to recruit some manpower, they have to fill up a job request form, give it to the HR. That is the starting point. And the onboarded person handed over to the department, that is the exit point. So draw the entry and exit point for the processes on which you want to do the value stream. Then draw all processes between the entry and exit point. So between the first and the last process, what are the sub processes are there? You have to just list all those sub processes. So before HR onboarding will be the job offer. Before that will be the final interview, oral assessment, analytical exam, tele-interview, etc. So just list all those processes, and then you just start collecting the data. So you just at the sub-process level, so try to collect how many number of people are there employed in that area, what is the yield in that particular area, and what is actually the process time. Process time is how much time actually is spent on doing that particular activity, right? For example, you are doing some turning. So how much time actually is spent only on turning, right? Because again, you may be setting up the machine, or sometimes the parts may be waiting for the setting and everything. So that is going to be a waste. But actually, how much of time is spent on that particular process, that is the cycle time. And moving from this process to the next process, on an average, how much time does it take? That is the queue time or the waiting time. So for each and every part, whatever you are going to produce, again, you just capture what is the process time, what is the waiting time, and what is the yield at that particular sub-process, how many number of people are involved, and what is the average inventory. So those type of minute details you start collecting for the process. And then you just see what is the total time. Once you have all the information, then you just see, so what is the total time taken, total turnaround time, right from the first one to the last one, what is the total turnaround time, and what is the cycle time. So cycle time is what is the time you are spending on only for the process. And then you will be able to clearly identify the choke point. Right? So here you are identifying this final interview as the choke point, because that is what is the most inefficient sub-process. And then you just try to focus only on that sub-process, and then try to split that into the activities. And then at the activity level, try to identify what are the activities which are not adding value to the customer. And then you take action, then your process will improve. So this is what is actually we call it the current state mapping. So whatever the data we are collecting, we call it the current state mapping. That at the sub-process level, try to capture all this information. We call it a current state mapping. So for example, this is what is the process. As an example I given. So receiving the order, processing the order, machining, inspecting, packing, and shipping, right? So, but this is what is the ideal flow. But when you are actually looking into your process at the macro level, so you will get something like that. There will be some choke points will be there. So again, as I was telling you, start collecting the data at each and every sub process. So what is the takt time or the how many people are working? So how much time it is the machine is up without any breakdown? So what is the yield? So what is the process time? What is the waiting time? So all those things you just capture. So this is what we call as the current state mapping. Then you know that, okay, so depending upon the data, whatever you collected, so try to identify the choke point, which is the choke point, and then see in order to improve the choke point, what is the problem you want to solve. So maybe here maybe the process time is more, or here the yield is very less, or here the changeover time is more or something like that. So you'll be able to immediately understand what is the problem. And then you try to solve the problem, right? And then you just do a future state mapping. So future state mapping is what actually you want to achieve. So you do in order to achieve the future state mapping, what are the actions to be taken, right? You just make an action plan, implement the action, and then after implementing the action, wait for 2 to 3 months for the improved process to stabilize, and then you do the value stream mapping again. So since you have taken action on the choke point, then definitely you will find that the flow has improved and your problem has been greatly solved. But again, don't just stop with that, and then say to see how you can improve it further, right? How to improve it further. So again, fix a tighter target, more ambitious target, and then again you'll identify some other choke point. So you repeat it within every 2 to 3 months. You do the value stream mapping. You will find that slowly but steadily your process efficiency will improve. So from here, you can see that this what is after the bottleneck is removed, right? So here maybe before, maybe you can see that somewhere you are finding instead of 1 minute, maybe you are finding some 2 or 3 minutes in the choke point. Because of that, everything was getting delayed. But once you have identified that choke point and taken action to remove that, then you will find that perfectly it's going to be okay. Okay. So free flow, you can see that no inventory, no waiting time, and everything is passing for the first time, right? So whatever the customer demand is there, so you'll be able to plan for that, and whatever you are planning, you'll be able to achieve. So you'll be able to achieve this future shape plan. So this is what is a simplified diagram. So balance flow across all the processes, high throughput, low WP, short lead time, happy customer. So improvement. So this bottleneck can be eliminated by balancing the capacity assembly. For example, if you find that here it is taking more time, so then you try to see whether you can improve the productivity here. If not possible, then you do the line balancing. See, maybe instead of one machine, you can just keep 2 machines here. Do the line balancing so that either if it is only reduced by only 10% or 20%, you can just see whether we can take action to increase the productivity. But if the difference is like here you are getting 1,000, here you are getting only 500, then see whether you can add one more machine so that the line is balanced, right? So that's one of the way of balancing the line. Then standardized work and the balanced line design. Then SMED, reduce changeover time. So somewhere you will find that maybe you are having some automatic robots you are having. So the changeover time is very high. So in that case, again, you can just work upon a tool which is called as the SMED, single minute exchange of time, which is a lean tool used for reducing the changeover time. Sometimes you will find that implementing these fibers and optimizing the layout, that may again help you to reduce the time. And sometimes you will find that the quality may be the problem. So yield maybe at this particular stage might be causing this choke point. So try to see how you can improve the yield. So depending upon the problem, what you are facing in the choke point, then you just work upon an action plan, improvement plan, implement it, wait for 2-3 months to allow the improved process to settle. And then again, you do the value stream mapping. You will find that dramatic improvement will be there. So now, maybe here it is only 500 pieces in the customer requirement. So you are able to do that. And then see for the next cycle, whether with the same line setup, whether you can try to do 600, right? So when you try to improve from 500 to 600, maybe you may find that the inspection is becoming a choke point. Then try to see what action you can take in the inspection area, so that again do this cycle. Then from 500 to 600 you go. Then from 600 to 650 you want to go. Then what to do? So one by one you take the individual sub process, improve. Then over a period of time, there will be a systematic improvement will be there in the end-to-end process. Right? So this is what is actually full-blown value stream mapping will look like. So these will be the symbols as per the international standard everything. So as I told you, the triangle is for the average inventory, cycle time, changeover time, uptime. That means without any how much time it is running, how many employees are there, and what is the yield, and what is actually the process time, and what is the waiting time. So you capture the current state, then identify the choke point, then try to identify what the problem is creating that choke point, then make an action plan to remove those particular problem, and then you'll just uh, after taking the action, wait for some time for the improved process to settle, and then again do the value stream mapping. So since you have removed the choke point, I take action. Then this choke point might be like might have been released, and then we will be able to achieve what the customer is wanting. But again, if you want to increase further, you want to supply more to the customer, then try to identify where the next choke point, for the increased output, where the next choke point is there. So like that, repeatedly every 3 months, you can do the value stream mapping. You will see that your process is going to, efficiency is going to improve, right? Okay. So any doubt or any questions on this? Any doubt or any questions? Are you able to understand the concept?
Sir Ramanathan here.
Yeah.
So once we found the where we are taking where the bottleneck is there, what we need to do for the key improvement points? Do we need to do RCA, or how we can
Yeah.
this key improvement points?
Yes, exactly. So that's why you are collecting the data, right? So suppose now you are identifying this as the choke point. So there already you have the time, right? Say for example, everywhere else cycle time is 1 minute. So here it is 3 minutes. So that means the process time is the issue, right? So as I was telling you, if it is more only by 20-30%, try to see whether you can improve the efficiency here. But suppose if it is 2 times, here you are taking 1 minute, here you are taking 3 minutes, then 3 times maybe you may not be able to improve the productivity. Then you will see whether you can add 2 more machines, right? So that the line is balanced. So that may be one of the action, either increasing the productivity or increasing the number of this thing. Line balancing can be the, if you want the cycle time issue. If the changeover time, if you are taking too much of time, you are wasting because of changeover, try to again use the other tool called the SNED and then try to reduce the changeover time. Uptime, sometimes the machine is frequently breaking down. So that's why it will become a choking point, right? Then try to see how you can solve the problem. Somewhere you may find that the yield is a problem, right? So try to, once you collect the data, you'll be able to exactly identify what is the choke point and what is exactly the problem. What is the micro level problem that is causing that. You take action on that so that the overall problem is solved.
Okay.
Now we will just quickly go through a problem. From maybe one of you can tell your problem. So maybe one of you can just tell about. So maybe can answer my questions. So which industry you are working? Which vertical you are working? Which domain? Maybe you would like to volunteer.
I'm supporting on finance and accounting operation. Is it okay? We can.
Yeah, sure. Okay. So you are in which domain?
You're asking me, sir?
Yeah. So we'll just try
Yeah.
to
Yeah. I'm supporting for a quality stock for a finance and accounting operation.
finance and accounting.
Yeah.
What is the product or service you are making? What service you are giving?
Service, finance service we are providing. So we will create the documents that will be used for projects and letter of engagement we used to create.
So the finance and accounting is what the service, right? That's the service. Accounting
Yeah,
service you are
yes.
giving, right? So you
Accounting
are
service.
okay. So you are giving the service to which? So this actually a service to
Infosys only. It's a internal client only. Our
this is
client
a service.
stakeholders is internal.
Yeah. So yours is a service industry,
Yeah.
and then the product or service is the finance and accounting. So what is the final output you give to your internal or external customer?
So we will be supporting on creating documents
What type of document?
like a letter of engagement, invoice processing,
So can
project
we take
code
just
creation.
only one? They are again for
Yeah.
each of this the workflow will be different, right?
Hmm.
So which one is the major one for you?
A letter of engagement. It is a kind of document that we will create.
So you are in quality department.
Yeah.
Okay. So now we will just see the end-to-end process steps, right? So now we'll take the
Okay.
help of ChatGPT. A financial service company, can I say?
Yeah.
Right? Am I right?
Yes.
The letter of engagement creative process in a financial service company. And the first let us try to identify the end-to-end process, right?
Yeah.
The end-to-end processes in that. Others, you can just imagine that you are doing it for your own process, right? So
Hmm.
I'm just taking, since it's a difficult one, if you are able to do this, then I think others will be easier only. I'm asking only to use the list. You just validate whether the list is right. Is it the end-to-end process?
So preparation. No. Or else I tell the process? Is it okay?
Yeah.
So
Is
we will
something
receive.
entirely different or something is not applicable?
No, not. It's different.
Okay.
So we will receive the request from the client through email.
Okay. Okay.
Once we receive the request, Sparks will be there. Spark will assign those requests to agents, respective agents, based on the service line.
Allocation of resources.
Allocation of task.
Allocation of
Allocation
agent.
of agent.
Okay.
Once the agent is allocated, they will start working on that creation.
Okay.
They will verify the request, all the details,
After creating.
validation of.
After
Yeah.
creating, after creating, or is verification
Before
is
creating, before creating, they validate the input request whether they have all the information.
So after allocation of this thing, validating.
Validating the request.
Okay.
Once they have all the information, they will create the letter of engagement document in a tool.
Okay.
In order management system tool, they will create a request.
Okay. After that.
After that, they will send it for audit, internal audit. Internal auditor will verify all the information are correct with that input they received.
Okay.
Once internal audit is verified, they will inform the requester about the completion of request.
The audit completion. Okay.
Yeah.
Then delivery, dispatch to the customer.
They
After
will
that,
notify the requester.
Notify?
Notify the requester about with the request ID creator.
Can I say delivered or notify the customer?
Notify the requester with the document ID.
Okay. This is the entire process, right? Okay.
Yeah.
Okay. So now, so you are operating in how many shifts? 8-hour shift or?
Sorry?
You are operating in how many hours or?
Yeah. 8 hours. Yesterday is 8 hours.
Okay. So your available time?
From morning 9 o'clock to evening 6:15.
Available time 9 hours, right? So 9 hours after removing the breaks and
Break
everything,
and all
it will be
8
480
hours.
minutes, right? 480 minutes.
8 hours.
Okay. So what? How many number of LOE normally you have to make every day on an average? So your throughput around.
Every day we will process around 50 to 60.
So I'll just put it as 60, right?
Hmm.
So available time is 480 minutes. So customer requirement is 60, right? So that's why we call it the takt time. So takt time is actually available time divided by the customer requirement. So that is 480 divided by 60. So I am just asking just to calculate the takt time. So that means every 8 minutes, one LE should be completed, right? So
Yes.
whatever these 12 sub-process is there. So for example, each sub-process should not make more than, say, for example, the first order comes, right? First request comes. So within
Hmm.
7 minutes, 8 minutes, this first one is passed, right? Then it goes to second one.
Yes.
So
Yes.
like that, every 8 minutes means if it is going to continuously come, then every 8 minutes you are going to get the output, right? So that is what is your
Yes.
expectation. That is what is your expectation, right? But for
Yes.
example, now this creating the letter of engagement is going to take instead of 8 minutes, it's going to take 12 minutes. Then what is going to happen?
So we will miss the SLA and then
Yeah, that means again it is going to be stopped. So here, this one will continue. A lot of inventory will be created here, and then 1 to 4 here, a lot of inventory will be created. Whereas 6 to 12, again there will be no work to do because this is becoming a choking point, right? So that's
yes.
where when we collect the data, so each and every, for example, the first request we are getting at 10 a.m. Then when it goes for this, maybe you are taking 2 minutes for the doing this process. And again, that job is waiting for 4 minutes till goes here, right? Till goes to the second one.
Yes.
Second process takes around 3 minutes. Then again, it waits for another 2 minutes because immediately it not go. Right? There'll be some in between, some waiting time will be there, right? So you just calculate it, and then if the total time, the process time and waiting time, if it is less than 8 minutes, then everything will go slow. Then everything will smoothly flow, and you'll be able to get the right one, right? But right now, if there
Yes.
is a choking point, then there will be a problem, right? Okay. So now,
Yes.
what is the problem now? So this 8 instead of 60, what is your problem? So are you getting only around 45, 50 like that? What is the current problem? What is the current your output?
Current output is around 40, and the major problem we are facing is uh, we are not receiving the proper input from the stakeholder. So after validation, again we are going back to requester and we are
Yeah,
requesting their
so
information
here,
again.
so let us not look into the problem. So we are going to create some not problem, a dummy data.
Okay.
So exactly your problem, maybe we may not be able to solve. So we are only trying to see how the process can be done, right?
Okay, I
So
understand.
we will not talk
Mhm.
about your specific problem, right?
Yeah, yeah, I understand.
So once you want to solve this particular problem, so your problem statement is so problem statement for the VSM project is currently output is only 40 and goal is to achieve 60, right?
Yes,
So I'll ask them to write the problem. First we start with the problem and code sheet. What is the problem and what is the code sheet? Write the problem and code sheet. So because of this, there is a productivity gap. We need respond to the customer request and it will be consistent maintenance, right? Goal statement is
yes.
increase the output from current 40 to 60 LOEs by eliminating the non-value reduction. So first start with, whenever you have such problem, first you try to see what is the takt time, right? So what is the expectation and what is the current performance, right? So
Oh,
based upon that, you will be able to define the problem and goal statement. And then we can just ask for customer time or will get that time. So now we'll just ask ChatGPT to create the dummy data.
okay.
Okay. So here you can see the process time for this is the end-to-end process, 12 processes. And this is the process time, how much time you are actually working on that, and waiting time. So how much time it is waiting till it is going to the next process, and what is the quality part of it, first time rate, how much percentage the first time rate, and the WAP. So what is on an average, how much of this process are waiting, right? So like that, you just collect the micro level data, right?
Okay.
So the total value added time is the time what actually you are spending on doing the work. So that is what is the value added time. Non-value added time is whatever the time you are waiting for that is the non-value added time. So the total lead time, you just add these two. So that is 450 minutes. So here you can see here, the choke point here is internal audit review. So 15 minutes is actually the time taken, process time taken, and 90 minutes is actually the waiting time. So that is the first choke point, right? And second one is about clarification loop, 10 minutes and 60 minutes. Clarify missing information. That's what you are saying, clarify missing information.
Yes.
So this is 10 and 60, right? So again, your data may be different. So you are telling that this is what is the problem. So this is only a rapid data, right? So you correct the data, then you'll be able to identify the choke point, which the process is actually choking, right? So required takt time is 8, but right now the so this is what is the current status, right? So now we are able to get the full current state map, right? So what is the current status? So this is the choke point we have identified. Then we will just ask for doing a root cause analysis. I'm just asking you to just identify only 6 reasons.
Okay.
So can we ask only for the clarification loop? Because you are saying that is
Yes.
what is the problem. So you can use the tools like 5-way analysis, cause and effect diagram, there's a fishbone diagram, then this
Okay.
waste analysis, 8 types of waste analysis, so that you'll be able to find the root process. So again, you can just classify them into people, process, and system, customer. Right?
Okay.
So these are the 6 root process. So clarify why it is causing. So you just try to, once you have identified the choke point, try to do a root cause analysis and then try to find out what are the root causes for that. And then we can just work upon a improvement plan. So for each of these items, indicating the tool used. Which sort of tool you can use, right? So design a standard client take form, create a checklist to increase the upfront validation gate, modify system, define clarification responses and ways together. So these are all some of the actions to be taken, right? So standard work, okay, so these are some of the lean tools. So we can also use this lean tools. So once you have finalized the actions and then implement the action, then again we can ask for the create the dummy data for the final future state paths. After these actions are taken, again we are doing this. So the total process time. So in current state, the total process time was 75 minutes. So that has come down to 42 minutes. Waiting time, previously it was 340, now it has come to 98. So total put together 450 minutes before and 140 minutes now. So all those things is given. So currently the bottleneck cycle time is approximately 8 minutes. Right? So available time is 480 minutes. So they will be able to produce these 60 kilowatt per day. So your target is achieved. So after making the improvement, then you can just make a prepare and sustaining plan. So monitor this continuously. So LO is completed per day, average lead time, clarification rate, first pass accuracy, audit. These are all some vital points, right? So if you are able to have a control over this, then overall you'll be able to achieve this. And escalation figures. So if the output drops below 55 per day for 3 consecutive days, so we have to have some sort of escalation mechanism, right?
Oh.
So this is at a very high level. So I think this is applicable for any type of problem, right? So you just try to identify what is your current problem, what is the problem, and what is the target you want to achieve. And you just see what is the customer demand, what is the available time. So available time divided by the customer demand, that will be your takt time. So if the takt time is coming, say 10 minutes, then in between the entire process, we are having 10 sub-processes. All the 10 sub-processes have to be less than 10 minutes only. Then only there will be a smooth flow will be there of the material. But somewhere 1 or 2 sub-processes, we are finding that the process time is more than the takt time. Then you identify which is the one which is contributing more. So that you identify as the choke point, and then try to split that choke point, try to focus only on that, try to understand what is the problem, why the choke point, why the output is lower there, whether the productivity is the issue or the maintenance of the running time is the issue, or the changeover time is the issue, or the quality rework is the issue, or something like that. Try to identify what is the real issue in that choke point process, and then take action. Depending upon the problem, you take action. And then after taking all the action and all the improvement actions are implemented, again, you just do the future state mapping. So since you have taken action on that, then you will find that you will be able to meet the customer demand. Then if the customer demand is next time you want to increase it to maybe by 5% or 10% increase, again, you know which is the choke point. So at each cycle, try to identify one choke point, one maximum 2 choke point. Try to work on the improvement plan, implement it. It will take around every 2 to 3 months. You do the value stream mapping, then you will be finding the substantial improvement you will be able to achieve. Okay. Okay. Any questions? Any doubts? So maybe this PowerPoint presentation and the recordings we will share with all the participants who have taken part. And if any one of you want to do it for your own process, then you can always get in touch with us. So then we will see how we can help you, right? Okay. So quick feedback from one or two, then we can close the session. Was it useful to you? So quick feedback. Avinash, so was it useful to you? You were able to learn something? Avinash Thakur? Okay. Elson Sabu? Okay. So anyone would like to give the feedback? I think you are giving the feedback in chat.
Yeah, Ramnadan here. It's
Yeah.
very helpful. Thanks for the session.
Okay.
Gopinath, yes, sir. It was really a wonderful information, and it's really new for me, and yeah, it was very helpful in terms of in knowledge. Yeah, thanks a lot. Thanks for the.
I think you are in logistics process. I think this will be very helpful. No?
Yes,
so
yes.
once
yes,
you get the order, till the time it is delivered to the customer. So many different process are there, and then you will find that again somewhere they are taking more time to process. Somewhere they are taking more waiting time is there. Somewhere more rework is happening. So you'll be able to capture all those information, and then you just identify which is the choke point, and then try to just focus on that choke point. Try to identify what is exactly the problem, and then you will be able to resolve the issue. But again, it is value stream mapping is not actually a single this thing, right? It's not a one-time job. So it has to be like every 3 months, you'll have to do a one cycle. So then definitely you'll be able to find a lot of improvement will be there.
Okay, sir. Noted. Thank you. Thanks a lot. I really appreciate that.
Yeah. Okay. Okay then. Thank you. Thanks, Ron. So try to apply in your real life this thing, and if you are facing any problem or you do not know, like you are stuck up in collecting the data, so you are not sure like how to collect the data and all. So as I was telling you, like we already have a Build to Brilliance, so that group we have. So that group we have just formed only for imbibing more and more knowledge to you, so that you'll be able to practically apply all these whatever you have learned, and then improve your processes and come up quickly in the layer organization ladder, right? So for that, don't hesitate to ask for any help. So try to send a message or WhatsApp message or whatever it is. Then we will definitely respond to you, right? So we have got a technical expert who will be able to connect with you, and then they will be helping you to solve your issues, right? So our main motto is our students should be able to learn and apply all those concepts in their real life problems. That is our. Okay. Okay then. Thank you. Bye. See you next time. Thank you.